asteroids and comets, once thought to be very different cosmic bodies, may be more closely related than previously thought. In 2005, NASA's Deep Impact spacecraft launched a projectile into the nucleus of a comet named Tempel 1. For the first time, scientists captured images of a comet's icy, muddy interior.
We think that material that's underneath the comet's surface is really in a pristine state from when the comet was first formed, which could be billions of years ago.
The Deep Impact mission concluded that some comets actually mimic asteroids. After a comet orbits around the sun many times, it loses its icy, gaseous components. It essentially becomes dormant, showing a dry surface that resembles a carbonaceous chondrite asteroid, which contains many water-bearing minerals.
We're looking at meteorites now, which we always assumed always just came from asteroids, and wondering, which of these could have come from comets. What that tells us is that there are many different kinds of comets. They've all had different histories, just like asteroids have.
Asteroids and comets have much more in common than just physical and chemical composition. They've both left deep scars on Earth, which have resulted in the extermination of life, time and time again. Near-Earth objects are asteroids and comets whose orbits bring them close to Earth's orbit. In the case of asteroids, Jupiter's gravity or light pressure from the Sun can bump these cosmic relics out of the asteroid belt. Similarly, the gravity from planet Neptune can nudge comets out of the Kuiper belt. The scars from asteroid impacts can be seen throughout our solar system. All the terrestrial planets and moons show the marks of these deadly blows, including Earth. 65 million years ago, a cosmic object, roughly 6 miles across, impacted the Yucatan Peninsula near the modern village of Chicxulub, Mexico. It produced kinetic energy equivalent to 8 billion Hiroshima atomic bombs. The impact event left a crater in the ocean over 110 miles across and 20 times as deep as the Grand Canyon.
Because the impact event hit the sea simultaneously, this created tsunami-sized ripples that then crashed onto the shoreline of the Gulf of Mexico. The energy and the explosive ejection of that material from the crater was so dramatic that that molten debris actually blanketed all of North America. Life as we know it would have been virtually erased.
Many scientists now believe the impact event extinguished 75% of animal and plant species on land and sea, including the dinosaurs. Planetary geologist David Kring is one of the foremost experts on asteroid impact events.
We now understand that impact events aren't simply a geologic process that excavates a bowl-shaped cavity, but one that actually can affect the environment, whether it be local, regional, or global.
In 2001, Kring headed up the Chicxulub Scientific Drilling Project near the impact site in the Yucatan Peninsula. Kring's goal was to find evidence that the Chicxulub impact produced worldwide climate effects by drilling down to the rock dating to that time period.
The drilling project confirmed our suspicions that the impact event had collided with a series of very important rock types limestone and anhydrite. The limestone, when vaporized, produced greenhouse-warming carbon dioxide, and the anhydrite, when vaporized, produced sulfuric acid rain. And so this confirmed some of the global climatic effects produced by the Chicxulub impact event.
The Chicxulub scientific drilling project also revealed that the impact generated hydrothermal systems that span the entire diameter of the crater. These processes provided critical environments for new life to evolve.
The extinction of the dinosaurs and the other life that disappeared 65 million years ago created new environmental and ecological niches. So the survivors were able to evolve and take hold of those new opportunities. The subsequent evolution has led to the formation or the evolution of our own species, the human species.
The next Chicxulub-sized impact is estimated to occur 35 million years from now. But one can never be too certain when it comes to space rocks.
Unfortunately, these types of things do not occur like clockwork. In fact, the next Chicxulub-size impact event could occur tomorrow.
Many scientists are confident that a cosmic impact was responsible for wiping out the dinosaur. But they're still debating about what type of rock.
We aren't actually sure whether this was an impacting asteroid or an impacting comet, although the bulk of the evidence points towards an asteroid. Asteroids, in fact, dominate the flux of impacting debris to the Earth. Somewhere on the order of 85 to 95% of the objects that collide with the Earth come from the main asteroid belt.
If we do find a comet on an Earth-threatening trajectory, it could be difficult to deflect or destroy before it inflicts apocalyptic destruction. Near-Earth objects are asteroids that have been dislodged from the asteroid belt into Earth-crossing orbits and therefore could again one day strike our planet. Although most potentially hazardous objects are asteroids, comets remain a legitimate threat. These icy bodies, which come from the outer solar system, can travel 3 times faster than asteroids, so it only takes 9 months for them to get from the orbit of Jupiter to the orbit of Earth.
You couldn't plan years ahead for an impact from most comets. You'd hear about it maybe a few weeks ahead, maybe months at the most.